So thanks to be here for this talk. I'm very happy. Well, you fought the fear of the coronavirus. I'm Nicolas Fränkel. I come from France. So a long way, so it's a bit strange to find only 4 people here, but really, again, I'm very happy. Do you understand my accent so far? No, I know that French people have shitty accent. I try a lot to downturn it, but the thing is that when I'm tired, it gets back, and so good. I've been doing a lot of development, well, like nearly 20 years in different positions, as a Java developer, architect, whatever. Mostly as a consultant, so working for different customers. And 1.5 years ago, I had enough of that, because if you are doing consultant work, you go to customers, there are different contexts, but in general, it's always the same problems. Those are people's problem, organizational problem, not technical problem. And then you have to fight your way through all that, and I didn't want that anymore. So I decided, I will be a developer advocate, so I will go to people and make talks, and if you don't listen to my advices, then that's fine. I work for a company called Hazelcost. Who knows about Hazelcost? 2 people, 3 people. If I wait a bit more, perhaps I will get, no, that's fine. So our first product is called IMDG, in-memory data grid, and basically you can think about it like a distributed data structure. So it's the same SPI as you would expect from normal, for example, normal map, but it's distributed. It's so simple that sometimes you make mistakes because it's very easy to use, but then it's distributed. And the other product that we have is Hazelcost Jet, and I will talk about it in more details a bit further down the talk. So this is the schedule. First, why do we do streaming? So I have a lot of slides about the history of why do we do streaming, the approaches, a bit about Hazelcost Jet, and then about open data, and about specification of the open data called GTFS. And I hope the demo will work, because last time it didn't, and Q&A. Everything that I will show you here is either open source or open data, so you can take everything. In the last slide, there is a link, and you can download the demo and do it yourself. Long time ago, the data was stored in SQL databases. That everybody was happy, but actually, it was not that great. Because even if everything was stored in SQL databases, there were certain kind of use cases that was not that good regarding SQL databases. And mostly those were 2 kinds, analytics, and my general use case is in France. You know, we have a big supermarket. Supermarkets have a lot of power. They are very strong in the economy. They are killing all the other components in the value chain. And basically, everything is sales-driven. And in general, the director or the head of the department, they want the sales number hourly. So that they can say, okay, we didn't sell enough last hour. Now, the next hour, we will make discounts so we can sell more fishes or whatever. And the other use case is reporting. And in general, you've got your monthly or your yearly bank accounts, and you have dedicated databases for that. The problem with SQL is, that's the trade-off. You've got the benefits of transactions. You've got the benefits of deduplication. In order to achieve that, you've got constraints and joins and normal forms, so that actually it's not that great if you want to just read data very fast. You have been taught in university that you should always normalize data, that duplicate data is bad. And we have been working like that for ages until NoSQL came. But for reads, we don't care that much. And also, the correctness is not that important. If I miss, well, on your back statements, it might be a bit of a problem. But for analytics, if I'm off by 0.5%, by 1%, that won't really change my decision in the end. And so there is a need for extract, transform the data, and load it somewhere else. Because the same database cannot cope with that. So we need to take the data, transform it, and put it in another data store. And it's called batch. And we have been doing that for ages. Who never have seen any batch? Yeah. Who here is a developer, by the way? Okay, what are you? You're not sure, or half developer, half ops?
Yeah, mostly system database.
Missed. Okay. Okay. If something is not clear, just ask me, because I'm very skewed toward development. Though I'm very interested in ops, I'm very skewed. So I assume that everybody either developed batches or operated batches. I mean, it's ubiquitous. Batches have two properties. They have a period of time they are intended to run in, and they run in a specific amount of time. And then comes the problem that you probably also have seen. It takes more time at some point to run the batch than the interval. At the beginning, everything is fine. You don't care that much about performance. They run. And at some point, data grows and grows and increases, and it takes too much time. Not that good. Also, the problem with batches is that they tend to load everything into memory. Again, if the data grows too much and you don't have enough memory, it doesn't work that good. Finally, I guess you also see that happen. If a batch fails during the execution, what do you do? To handle the fact that the data can grow, like 15 years ago, started the big data movement. So the big data movement is just as simple as saying, well, just as simple, but it's very complex in the end. But the abstraction is very simple. Just say, oh, let's distribute the batch on different nodes. Like in general, the usual traditional SQL database, they are not distributed. They mostly run on one node. And if you have good admins, then you have like one master node and slaves. If you have like failure, then failover occurs, then it elects a new leader. But the idea to run like, to do horizontal scaling was basically like very old, but very hard to achieve. And this big data movement and all its technology is exactly that. Let's distribute everything over several machines so that we can scale horizontally, and we are just limited not by the physical world, but by the money we have, because we cannot buy that many nodes. And I also mentioned the schema on read versus schema on write. So in this NoSQL say, oh, let's remove all the constraints, all the joins, let's like duplicate data if the need be, we don't care that much. Regarding the fact that it can fail midway, big data says, okay, every step along the way, we will store the stuff in a persistent file system. Or what you can do if you don't do big data, you can try to handle the data in chunks. And then you keep the cursor, say, oh, sorry, I failed during this last execution, the cursor was in this, so I need to redo from this point. But meanwhile, new data might have come in, and then it's another issue. And then comes event-driven programming. The old stuff that, again, you were taught at school regarding interacting with user interfaces. People decided, that's a cool idea. Why cannot we treat data like that? Like instead of handling clicks, then every time something happens, an event, then we have an observer that listens to that event being triggered, and we can react on that. And we can store all those events and replay them or aggregate them or do whatever we want with them. And if you think about that, the fact that events happen in order, in an immutable log, it's how a database themselves are built internally. Actually, I don't know, you might have heard about something called Debezium that reads this log to send events. So the solution is simple. Again, from an abstraction point of view, you make everything event-based. The good thing is you don't need now to keep everything in memory. Every time you've got new data, then that's a new event. This is very memory friendly. This is much easier to process one event than a whole bunch of data. And on the other side, you've got pull instead of push. So you just need to register, and then you are kept informed about the new events, and then you can process the data. This is close to real time, actually. And finally, now you can handle infinite data sets. Because in general, data is infinite. It's only our mind that tries to make it finite. Like, I was telling you about your bank account, but you can always add more operation. Of course, in 1 month it will be finite, but otherwise, until something bad happens to you, or you close your bank account, then you will always keep appending stuff. And streaming is just this way of looking at things. Streaming is a way at saying everything is an infinite stream of data. And then you can apply everything that you did in your batch to that stream. And that unlocks a lot of features. I mentioned the decision-making process regarding analytics, and the issue with that is that you need to wait until the end of the hour. So you cannot react before. So you need to wait 60 minutes before you understand that the numbers that you were given tells you, hey, you should do a discount. But if you already think that, after 40 minutes, there is a 95% chances that actually you should offer a discount on fishes, that's crazy to wait 20 more minutes. So the fact that you stream gives you perhaps less correct data, but good enough so that you can make your decision faster. What you can do also, and now it's going like super hype, you can take this stream of data and instead of doing like old batch process, you can apply some machine learning stuff on it. And for example, a video is just a stream of images. And finally, if you have been old enough in the development world, you might remember something called complex event processing. That's like the machine learning of old, that we were trying to define the rules by ourselves and not have some algorithm determine the rules for us. So if you are still having these complex event processing dreams, then you can do it now. Now, the events might be a stream, but in general, we still want to keep them somewhere on the disk. Right now, the leader is definitely Kafka. Who knows about Apache Kafka? Okay. I've heard multiple times the Apache Pulsar. That seems to be a strong competitor. I have no experience in Pulsar, so I cannot say whether it's better or not. But if you are interested, you should keep an eye on it. So Kafka is distributed, it's persistent, and it's like the old queues from old. The only difference is that you keep the messages there. And then you have consumers that can read the messages. And also, the huge difference is that the consumer itself keeps the offset of the last read record. So you can decide to read from an earlier offset or a later or whatever. The good thing is you can have multiple parallel consumers, each having different speeds, and one will consume the events faster, and so advance the offset faster, and the other might be slow. That's not a problem. Everything is possible. That's good with persistence. The downside of persistence is that you need to write on disk, and whether you like it or not, writing on disk is much, much slower than having everything in memory. And for example, about my examples before, about the analytics, I don't care that much about the aggregation of the sales in the last hour afterwards. What I want is I want the result as soon as possible and then discard it afterwards. So in that case, in-memory streaming makes a lot of sense. And you've got a lot of them. Flink, you can have like cloud-based one. You have Jet, of course. You have Beam. That is an abstraction over several real streaming, in-memory streaming engines. And it's interesting, of course, since it was an abstraction that was like designed afterwards, then it's not a really good abstraction, but it's still an idea to say, okay, we will hide the streaming engine behind an abstraction, and then you can like replace it if you are not happy about it. Not sure it will be working, but it's interesting. And Jet is an Apache Beam implementation, by the way. Hazelcast Jet. So again, it's open source. You have got a single jar. That's one big benefit. You can use it embedded in your Java application, or you can use it in a client-server mode. And we have an API that is very similar, whether you do streaming or batching. So you can start to do batching, and then after you get more familiar with the model, how it works, then you can like go to streaming in one line of code. So yes, we have like something that is not open source because I need to be paid to get here, but that's understandable. Every streaming engine needs to have sources and sinks, and Jet is no different. So if you want to compare by yourself, so I'm not trying to sell you Jet, but I hope you will make some comparison by yourself. You need to check what is available out of the box for sources, for sinks. In general, all those operations here are mostly the same. But the real important point is how many out-of-the-box sources and sinks are available, and how easy it is to create a new one by yourself, because of course you will have specific needs that is not covered by the ones here. Jet has two concepts, the concept of a pipeline and the concept of a job. So a pipeline is basically defining the source, the transformation you will make in the pipeline, and the sink. And once you've got the pipeline that is defined, then you can send it to the streaming engine and it will become a job. And then the streaming engine will execute the pipeline, it will execute the code. Very important, it will also create the directed acyclic graph. Now I must think, because we always call it the DAG, but DAG doesn't mean anything. The directed acyclic graph, and trying to distribute the load over all the nodes when possible. Of course, you want to parallelize everything as much as possible. Some operations are not parallelizable, so you can say, oh, this one, no, you cannot distribute it, you must keep it on one node. Who here doesn't understand that code? It's fine, I can explain it. This is Java code. Okay? So this is what we did a long time ago to, well, count the words. You have a string, you create your hash map, and then you say, okay, I will split by space, I will count the words, and if the word doesn't belong to the hash map yet, I will put 1. If it already belongs to it, I will increment the count. The problem with that piece of code is you are focused on the how. And in general, today, we are more focused on the what. Because we want our libraries, we want our abstractions to do that and to optimize it. We are very bad at optimization in general. I mean, I'm very bad at optimization. So it's better to have an API that describes the what, and the implementation does it in a certain way. This is the same, but using the new Java, well, new, a couple of years ago, Java 8 streaming API. This is exactly the same, but at least everything can be nicely optimized. And if you do Java, you know that by here, changing stream by parallel stream will distribute the load over all the cores. So at Hazel cost, whether IMDG or JET, we can create a cluster very easily. You start your Hazel costs instance, and then it will multicast, try to find its siblings. Of course, you shouldn't do that in production, because you want everybody to know about where it belongs, and it's not very secure. But in development, it's very easy. You just start Hazelcast, it multicast, it creates a cluster. Everything is fine. And then you can distribute the load all over. And, I mean, it's distributed system. So basically, if you want to store like something in a hash map, it will hash the key and check which nodes the key should belongs to, and after some point, in general, you will have failure or you will have more nodes because you want to scale. It will rebalance everything. Everything should be done for you. You might notice that this is JET API. This is very, very similar to what we did with Java 8. This is very functional. You are focused on the what, not on the how. So here you will say, hey, I will read from this hash map of book lines, and then for every line, I will split the line into words, and the words now are the elements, and if a word is empty, then I remove it, then I group by word, then I count by word, and I put it in IMDG again. So very, very similar. This is how you can think about it. Data is distributed, so it will be read from multiple nodes, and in each node you might have multiple threads. You map, you filter, you aggregate, you combine, and then it gets back here. Again, here, it's very easy because this is an algorithm that can be distributed. Again, some algorithm cannot be distributed. You must be aware of that, and then you must say, oh, this, for example, this operation, it should not be parallelized. And now comes open data, because the talk was called streaming and open data. So Open data, I believe, is very important because we focus for a long time on the software itself, on the process itself of the data, but data for a long, long time was very private. And even now, it's very hard to get access to some of it. But this has started to become more and more ingrained in people. And actually, I don't know about the US, because I come from Europe, but in France, the French government has an initiative on open data, the Swiss government has an initiative on open data, the European Union has an initiative on open data. So they are all very focused on open data, because they believe that if you give the data to the people, some people will be smart enough to do something useful with it. But it's not easy. Problem number one, access. Is it a web service, or because it's an administration that knows nothing about computer software, they just give you a link to the file? In general, it's a link to the file. Not great, but okay. Second, format. In general, open data means open format. But sometimes, open data means Microsoft Word. Not great. And even if it's an open or not so close format, it's not super cool to try to scrape data out of a PDF, believe me. And third problem, the standard. Let's say that the administration was kind enough to give us XML. Great. Do you really think they gave you a grammar? And even if they did, probably it's not the same grammar that they used in Switzerland and in France. Or perhaps you know that Switzerland is also a federal state, so perhaps two cantons give the same data in different formats, even if it's XML. So we probably need some standard that is ubiquitous. But you probably know these XKCD comics that if you've got 14 standards and somebody say, oh, I will create one standard to unite them all, in the end you will get 15 standards. And finally, the fun part, and I can show it to you in the demo, is yes, those are hours of the day. Who can tell me what time it is? You know, I'm not a data scientist, but I read sometimes some articles, and I see a lot of them telling, oh yeah, most of the part, like 80% of our job is to curate the data, because the data that we got is really awful. They are not joking. That's true. So once you overcome all those challenges, you might get something. And I became interested in this GTFS. So it's a specification made by Google. Not that great, but it's an open specification for transit information. And interestingly enough, the site itself is Creative Commons, and the code snippets inside are Apache license, so you can use them. And they define two things. They define the static model, and so I won't read it, but I mean you can define the stops, you can define the routes, the trips, blah, 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 everything. You've got a lot of them. And you've got the dynamic model. Cheers. Again, I won't read everything, but it's just to show you that it might be a bit complex. And now I want to use that to display all the Swiss public transportation. Great stuff, it's open data. Even better, it's GTFS. So I downloaded the file, and now I can call a REST endpoint and get the dynamic data. And when I call the dynamic data, I don't have the whole data model. So before, yeah, the screen is a bit small, but I had this vehicle position here. Great, cool. Now I use this and I don't have the vehicle position anymore. And that's where data streaming comes in. So here, what I get is what they call a trip update. And a trip update is a collection of stop time updates. And basically, they tell me, you know, regarding the timetable that was planned, the 5th stop will be 60 seconds late. So I need to think, okay, so basically, this stop normally is located at this position, and they will be there at this time. I have the previous position, I do the same, and now I can interpolate between the two. And that's what I'm doing. So the source is a web service, and I split every call. The trip gives me like a huge JSON, and I split it into like different trip updates, and I enrich it with the trip data that I loaded previously, then with the stop times data. I got the hours into the timestamp because my front-end developer wanted to use timestamps, and then I get the location data and I put it in the hash map, like distributed hash map. And this is the architecture. I have the streaming engine. This box is a streaming engine. The first thing that I do is I load all the reference data that I previously downloaded. So I send the job to Jet that will read the files and store everything into my EMDG. And once this is done, and it takes a bit of time because the files are quite huge, so I already did it on my machine, then I can send the dynamic data loader. And this is a job that will call the REST endpoint at regular intervals and do the processing that I've shown you in the slide before, store everything in a different table in IMDG, and I have my web app that registers changes. So every time there is a change by this job, then I am aware of that and I can react to it. And then I can send it to a WebSocket. And again, on the front end, I register to this WebSocket, so every time there is a change, then the WebSocket endpoint, the front end, the JavaScript can react to it. And it's time for a demo, so just that we are on the same page, the last time I did this demo, it was a failure, a huge failure. So just to manage the expectations, the good thing is since that time I learned about it, so I did a movie. So even if it doesn't work, now I can show you the movie and not look like an idiot in front of you. Like, because if you cross the Atlantic to look like an idiot, it's not that great. Is it big enough? Here I cannot make it bigger, unfortunately. So I have my two main jobs, like the load static stuff that already was executed, and the stream dynamic one that I want to show you. Before, perhaps I can use Postman just to call the web service once and see the JSON payload that it returns. No internet connection, that's not good. I want an internet connection. And now, yes, great. Send. So I'm asking about the latest dynamic data, and it gives me this stuff. So for example, when I say I want to split, here I've got a lot of like stop time updates, and I want every time to split it. It's long, I won't go to the end, it's really, really long. So here I have another trip update. So the first thing is to split them into different entities so each of them can be processed. And as I mentioned here, every stop time update has like a delay regarding the departure or the arrival. So here, since it's the first one in the sequence, it's deported on time. But here, even though it's the second stop, then there is already like a 1 minute delay when it will arrive at the next stop. And here you can see I have no clue about the location. That's why I will get the location from the stop ID that was already stored in the IMDG. The fun stuff, it's sometimes also, it skips a sequence. So here it's good, yes. Here, for example, stop sequence 7, stop sequence 9. And the 8th?
Maybe somewhere else.
Maybe it just disappeared. So what I assume here is that if there is nothing, I assume it's on time. Because I already have the trip. So I say, okay, if it's the 8th, it will be on time. So I will stream the data live. Ta-ta-ta. So now it has sent the job here. So you can see that I've made a call to the web service and I received the result. I've split. I've handled all the process and every time I output, so to be sure that something is working. Now I will run the application. It works. Amazing. The routes that are in gray are not used at the moment. The routes that are in red are used and are trains, and normally at some point there should be green ones that are buses. And you can see that if I will go a bit closer, the interpolation is done on the client side because that was a bit too much. And this one is the Interregio 15, and it should go to next one, Zofingen. Yes, Zofingen. Here I am limited by the front end. Like if I let my Spring web application like send everything it can, at some point the front end says like cries uncle and say, hey, you are sending me too many events, I cannot follow anymore. So I'm introducing a slight delay, but of course then it's not that good. Then the map takes a long time to load. So after some time, you can have something like this. I will show the video because now you've got everything here. Okay. So here, I've let it run for a long time, and you can see you have green lines, you have red lines, you can see the name of the stations that I've shown you, you can see the name of the transport itself, and you can see it like slightly moving. Of course, right now it doesn't follow the exact rail station because I'm not good in front end and my colleague didn't have enough time. So if you are interested in contributing, I will be super happy if you do, because I have no clue how to do it. But I mean, it's a good approximation, I believe. So let's get back to the presentation. Streaming has a lot of benefits. I've tried to highlight of what I've shown you to do that in California. Here are the specification, and here is the GitHub repository. So if you want to fork it, I will be happy. If you want to contribute to it, I will be super happy. And now I have a couple of minutes for questions, and I will be happy to take them.
Have you ever reached out to the providers of the data to see if you could answer the question as to why that the one stop was missed? Or do you just deal with the data? Do you just roll with it?
I'm a developer. I don't talk to people unless I'm forced to. So here I didn't reach out to them, and I just assume it's like that. And besides, I don't care that much. It's a demo. But yeah.
So working? So I know Hazelcast only as like a caching product, essentially an in-memory database. Is Jet just like a append-only type of data store that's been added onto it, or?
No. So first, just we offer an in-memory data grid that most people know that they use for caching, but we have a lot of other use cases. I will probably need to write a blog post about that. We don't only have an IBAP, you can have queues, you can have locks, you have atomic longs, you have a lot of stuff. Okay? Now, about your question of Jet, it leverages the in-memory data grid, but it still runs in memory.
So there's no, storage component to it? Or?
There is no storage. Nothing prevents you from having to write, in the end, you sync to Kafka, or your source is Kafka. The point of Jet is to do like stream processing very, very fast. As soon as you go on disk, you can keep the data, that's great, but you are much, much slower. So it depends on your use case. One of the where we are really, really very good is in fraud detection, for example. We have a lot of financial institutions using Hazelcast Jet for fraud detection, because you don't really want to keep the result in the end. What you want is to have very, very fast result. So when the customer gets the result very fast.
Processing.
Yes, stream processing. Yeah.
No, I'm processing.
You're processing. I can stay a couple of minutes afterwards, though I have a flight. And if you once you have processed everything, if you have more questions, I will be happy to answer.
I actually work in fraud detection, and I would argue that we absolutely keep all of the data so that we can use it later for retraining models.
Okay. Yeah. Then that's also a very valid use case, but then it's a trade-off.
I had a question about idempotence. Are you enforcing that? Is that a thing that's handled, or is it something you just have to know and do that?
No, we have at least one semantics. So basically, if you send the same data twice, it's up to you to define a unique ID and to say, I already processed it. Or you don't care. Again.
Use case.
Yeah, use cases. But we try to be as simple as possible because we want to be fast. And if you want to be exactly once, it's a lot of work and complexity.
Indeed.
Are you familiar with the German transport company Flixtrain and Flixbus?
Nee, bin ich nicht.
Okay.
No, I'm not.
Okay, that's okay. They have recently expanded into the US, and I noticed that they have an API for their data, and I wondered if you knew if it was in GTS format. So
no, I don't know.
That's okay. All right. Thanks.
I do actually think that LA Metro does publish data very similar to this, and you can actually have an app that shows you where the buses are on the map and where they're going to get to.
Yeah, and the most important stuff is even if it's the same specification, probably you will get different data. Here, you know more or less, and you need to process everything to infer the location. But imagine that you have GPS chips on your trains or whatever, then you can have the real locations in real time, And you don't need all that. Perhaps you don't even inject in that case. And that would be pretty cool.